Okay, so let's get right into it, because this is one of those things that sounds like a riddle. Why is America's space agency, the people who look up at the stars, spending so much time and money exploring the deepest, darkest, most crushing parts of our own oceans? Well, the answer is incredible. It connects the very bottom of our world to the search for life on a totally different one.
You might not know this, but off the coast of Florida, about 20 meters down, there's a place called the Aquarius Reef Base. It is literally the world's only underwater laboratory, and every year NASA sends its astronauts to live there. They even call them aquanauts for this mission, which has the awesome name Project Nemo. That stands for NASA's Extreme Environment Mission Operation. But they are going way, way deeper than that. NASA has this autonomous vehicle called Orpheus, and it's exploring a place called the Hadal Zone. We're talking nearly 10 kilometers straight down, and just to give you an idea of how insane that is, think about the Titan submersible tragedy. That imploded at just 3.5 kilometers. NASA is working at almost 3 times that depth. The pressure is just unimaginable.
And this quote just nails it, right? We have better maps of Mars than our own ocean floors. In so many ways, the deep ocean is a far more alien and mysterious place than the surface of other planets. It is the real final frontier. And it's right here on Earth.
So, here's the big twist. NASA isn't down there looking for aliens in our oceans. They're not expecting to find some sea monster. They're there for a proof of concept. They believe the origin story of life on our planet gives them the perfect blueprint to find life somewhere else in the solar system.
See, according to scientists, for life as we know it to get started, you really only need 3 basic things. Think of it like a recipe. First, you need a liquid medium, something for stuff to happen in, like water. Second, you need chemistry, the basic building blocks, carbon, hydrogen, oxygen. And third, you need a spark. You need some kind of energy source to kickstart the whole process.
But that brings up a really big question. Down in that deep, pitch-black abyss, miles away from the sun's light, where in the world did that energy, that initial spark, come from? This totally shatters that idea we all learn in school, that all life on Earth depends on the sun. And the answer is hydrothermal vents. These things are basically underwater volcanoes. They're not powered by the sun at all, they're powered by the raw, incredible heat from the Earth's molten core. This proves that life on our planet didn't start in the light. It started in total darkness, fueled by geothermal energy.
The water blasting out of these vents is just staggering. It can hit 400 degrees Celsius. That's hot enough to melt lead. This was the primordial forge. This was the raw, violent energy that was powerful enough to smash simple elements together and create the first complex biomolecules, the very first hints of life.
Okay, so now we have our model. We know what to look for. A deep, saltwater ocean kept warm by geothermal energy coming from a planet's or moon's core. That seems to be the perfect setup for life. So the next question is pretty obvious, right? Where else in our solar system do we see that exact same environment?
Well, the answer takes us way, way out into the solar system, to Jupiter's 4th largest moon, a little ice ball called Europa. All the data we have suggests this world is hiding a massive secret under its frozen crust, and that secret makes it the #1 prime candidate for finding alien life.
So you might be thinking, hold on, how can a moon that far from the sun have liquid water? It all comes down to this incredible process called tidal flexing. Jupiter's gravity is so immense that it's constantly squeezing and stretching Europa like a cosmic stress ball. All that friction generates a ton of geothermal energy deep in its core, and that's the heat that keeps its giant ocean from freezing solid. That's the energy source.
And the sheer size of this ocean is it's hard to wrap your head around. It's estimated that Europa's hidden ocean has twice the amount of liquid water as all of Earth's oceans combined. So we're not talking about some little pond here. We're talking about a massive global sea.
So, let's run down the checklist. Does it have a liquid saltwater ocean? Check. Does it have a geothermal energy source from tidal flexing? Check. And does it have the key chemical building blocks? Well, data confirms stuff like carbon and sulfur right on the surface. Check. It has all 3 ingredients.
And that is exactly why NASA is about to launch one of its most ambitious and expensive missions ever, the Europa Clipper. It's a multi-billion-dollar probe built for one specific purpose: to fly to that distant moon and figure out if it has what it takes to harbor life.
The journey to get there is a masterpiece of orbital mechanics. It's launching in October 2024, but it's not flying in a straight line.
Oh no. It's going to travel over 1,600 times farther than our moon by playing a kind of cosmic pinball. It'll get a gravitational slingshot from Mars, then loop all the way back to get another one from Earth just to build up enough speed to finally reach Jupiter in 2031.
So once it gets there, phase 1 begins. The Clipper is going to do a bunch of flybys of Jupiter's other big moons to get its trajectory just right, and then it'll settle into a long-term orbit around Europa. From there, it's going to use a whole bunch of really advanced instruments to scan that ice shell, figure out what it's made of, and look for giant plumes of water vapor that might be erupting out into space.
But here's the thing. The Clipper is really just the scout. It's the beginning. The data it sends back is going to lay the groundwork for a follow-up mission that sounds like it's been ripped right out of a science fiction movie.
The plan for Phase 2 is to land a series of nuclear-powered cryobots on the surface. These robots are designed to do one thing and one thing only: melt. They'll use their own heat to slowly, painstakingly bore a hole through up to 20 kilometers of solid, rock-hard ice. It's a journey that could take years, but eventually they'll punch right through into that alien ocean below.
And it gets even crazier. Once a cryobot breaks through to the water, it's designed to release a swarm of 48 tiny, swimming micro-robots. Can you imagine? These little explorers will just spread out and start swimming through Europa's dark ocean, actively looking for any sign of life.
Now, it's super important to remember something here. This whole incredible search, this entire grand plan, is based on the only model we have for life: us. Life on Earth. We're looking for carbon-based life that swims in water. The universe, though, it could have easily come up with life in ways we can't even begin to imagine.
But you know what's so beautiful about this? Even if the Clipper and the cryobots go all that way and find absolutely nothing, the mission is still a massive success. The very act of trying to answer a question this big is what pushes our entire civilization forward.
Think about it. These huge, curiosity-driven missions are what force us to invent revolutionary technology. They make us solve problems that seem impossible, and in doing that, they unlock our greatest potential. They bring people together from all over the world in this amazing, shared quest for knowledge.
Gaurav Thakur, who is the source for this whole explainer, he put it perfectly. He said, "This is the beauty of humanity. It is just pure curiosity. That's it. That's the thing that drove us out of the caves, and it's the very same thing that's now driving us to an alien ocean hundreds of millions of miles away."
And all of that leaves us with the biggest question of all. After all these centuries of humanity staring up at the stars and just wondering if this mission works, if we finally get the confirmation that we are not alone in the universe, what happens the next day? What changes?